We will now continue with section 4.5, discussing specifically the rational inequalities. A rational inequality is any inequality that can be written in the form f of x is less than 0, less than or equal to 0, greater than 0, or greater than or equal to 0, where f of x is a rational function. Now, we do have a procedure table for solving these rational inequalities. Basically, this procedure table says that we need our rational function to be in reduced form. We then need to find the real zeros of the numerator. We need to find the real zeros of the denominator. We need to place the values from steps 1 and 2 on a number line, splitting it into intervals, and then choose test points to evaluate the function at each of those intervals. The last step is to write the solution set, consisting of all the intervals that satisfy the given inequality. Now, as always, as we work an example, we'll reference back to these steps. So our first example says x squared plus 1 over x squared plus 2x minus 15 is greater than 0. So remember that we start by finding the zeros for the numerator and for the denominator. The numerator has no zeros because when we set x squared plus 1 is equal to 0 and solve for x, we can see that it is impossible for us to take a squared value and have it equal -1, at least in the real number system, because when you square a number, it is always positive. So there's nothing that comes out of the numerator. For the denominator, x squared plus 2x minus 15, we will factor this into x and x. 5 times 3, making 15. And remember, the positive 2 indicates that the bigger number, the 5, should be positive and the smaller one should be negative. And so out of this one, we will get an x value of -5 and an x value of 3. So our next step is to split the number line according to these zeros that we came up with. So we're going to draw a number line and we're going to mark off the -5 and the +3, which basically takes our number line and splits it into 3 sections. We have a section here, a section between -5 and 3, and a section between 3 and infinity. We then want to choose a test point in each section. So we might choose -6. -6 is to the left of -5. We might choose 0 as the middle section, and maybe we choose 4. All right, so these are our test points. Okay, so let's go ahead and kind of look at this in a table now that we've done this. All right, so our first interval runs from -infinity to -5. That is this first section of our number line right here, -infinity to -5. All right, and we said that our test point was going to be -6. All right, so what we want to do now is we want to plug that test point into our original problem. So remember the original problem, let me just write it up here, x squared plus 1 over x squared plus 2x minus 15. And so we're going to plug a -6 in for the x. All right, and we're not even that concerned with the number that we get, even though we'll write it down. We're really concerned with whether it's positive or negative. So on the top, we're going to have -6 squared is 36, plus 1 is going to be 37. On the bottom, we're going to get positive 9. And so 37 over 9 is positive. Okay? And so what that tells me is that for any number in that interval, the function is going to be greater than 0. that it's going to be positive. Okay, so let's go back. Now we're going to look at this middle interval. So -5 to 3, and our test value is 0. All right, so here's our interval, -5 to 3. We said the test value is going to be 0. And we're going to plug 0 into our function up here. So we'll have 0 squared plus 1, 0 squared plus 2 times 0 minus 15. On the top, that's going to give me a 1. On the bottom, it's going to give me a -15. And so our answer will be negative. So what we can conclude is that our function is going to be less than 0 for all x's on the interval from -5 to 3 because we got a negative number out. All right, and then finally we'll look at this last section. So from 3 to positive infinity, and our test value was 4. So from 3 to positive infinity, our test value was 4. We're going to go back and plug 4 into our function. So our function is going to be x squared plus 1. So we'll have 4 squared plus 1. On the bottom, we have x squared plus 2x minus 15. So on the top, 4 squared plus 1 makes 17. On the bottom, we're going to get, just using the calculator here, so we'll get a positive 9 on the bottom, which is going to give me a positive result. So again, this means that my function is greater than 0 for all x's on the interval from 3 to infinity because I got a positive number out. So what we're going to do now is we're going to go back to our problem for a second, and we're going to ask ourselves whether we want the positive intervals or the negative intervals as our answer. The problem has this greater than 0, so we want to be asking ourselves what kind of numbers are greater than 0? Are those the positive numbers or the negative numbers? So we know that those are the positive numbers, the numbers that are greater than 0. And so we go back to our chart, and we want the intervals where we have the positives. So we want this first interval from negative infinity to -5. So we definitely want that one, negative infinity to -5. And then we also want this one because this one is also positive. So 3 to infinity. And so solving our inequality, we have the interval from negative infinity to -5 union with the interval from 3 to infinity. Okay, so we're going to try one more problem. This problem is sort of a two-part problem in that most of the work can be done for both inequalities at the same time. We have a problem that says x over x plus 2 is less than 3, and then we have a problem that says x over x plus 2 is less than or equal to 3. So really our work is not going to change. All right, so the first thing that we need to do is we need to move the 3 to the other side. Okay, we need to have this inequality set equal or less than or equal to 0. All right, so we have a little bit of work to do before we can get started. So I'm going to take that positive 3, and it doesn't really matter which equation I work with, but I'm going to subtract it off. Okay, and then I need to combine these. So I'm going to combine them by doing a common denominator. So right now the common denominator will be the product of the two denominators that I have. So it'll be x plus 2. So the first fraction is good. The second fraction, the 3 over 1, we need it to have an x plus 2 on the bottom. So I'm going to multiply top and bottom by x plus 2. So this is going to give me x over x plus 2 minus, we're going to distribute this 3. So minus 3x. We want to be careful here. So minus 3x and then minus 6. Be sure that you are distributing that negative through. And this is all now going to be over that x plus 2 because we have that common denominator. All right, so we end up with, combining like terms, negative 2x minus 6 over x plus 2 is less than 0, or it can be less than or equal to 0 depending. Okay, so remember that our procedure table, once we have it set equal to 0, is to look at what makes the top equal to 0 and what makes the bottom equal to 0. So if I take the numerator and I set it equal to 0, and then I add 6 to both sides, so negative 2x is equal to 6, and divide both sides by negative 2, I have x is equal to negative 3. And if I take the denominator and set it equal to 0, we have x is equal to negative 2. So when we think about our intervals, we're going to break our number line at negative 3 and also at negative 2. So if I draw a number line, I want a break at negative 3 and a break at negative 2, which again is going to give me 3 intervals to work with. I'm going to have the interval from negative infinity to negative 3. I'm going to have the interval from negative 3 to 2. And I'm going to have the interval from 2 to infinity. So we'll go to our chart, and we can see that we have those 3 intervals noted. And we're going to pick a test point in each section. So I might choose x is equal to negative 4. I might choose x is equal to negative 2.5. And I might choose on this last one, x is equal to 0. And then we need to evaluate. And we're going to evaluate back in our original function. So, well, our original function once we have it set equal to 0. So we're going to be evaluating in the function negative 2 x minus 6 over x plus 2. All right, so let's plug a negative 4 in and see what we get. So negative 2 times negative 4 minus 6, negative 4 plus 2 on the bottom. So I'm going to get a positive 8 minus 6 will be 2. Negative 4 plus 2 will be negative 2. So we're going to get a negative answer out here. So what this tells me is that my function is less than 0 on the interval from negative infinity to negative 3. Okay, now we're going to plug in the negative 2.5. So we'll do that the same way. We're going to plug in negative 2.5 for the x's. All right, so that is going to give me a negative 1 on the top and a negative 0.5 on the bottom. So negative over negative is going to be positive, which means that the function is going to be greater than 0 for all x on this interval. All right, and then we'll do the last one. So we'll plug in 0. So we're going to have negative 2 times 0 minus 6 over negative 2 plus 2. Okay, and I'm plugging in a 0. I've got a mistake here somewhere. So negative 2 times 0 minus 6. Okay, so this should be 0 here. All right, so on the top, that's going to give me a negative 6 and a positive 2 on the bottom. So that's going to give me a negative result, which means that the function is less than 0 for all x on the interval from negative 2 to infinity. Okay, so now we need to go back and we need to look at what we are trying to find, whether it's the positives or the negatives. So here is your function that we're working with. It has a less than 0, which means that we are looking for the negatives. Remember that negative numbers are less than 0. So going back to my chart, let's note the negatives. So there's a negative. And here's a negative. So we're going to take those two intervals. All right, so definitely the interval from -2 to infinity. And then that first interval was the interval from -infinity to -3. Okay, so now we have to be a little bit careful here with the way that we have this problem worded. Okay, so remember we had two problems initially. So our first problem was x over x plus 2 is less than 3. And then our second problem was x over x plus 2 less than or equal to 3. All right, so the intervals as we have them written answer the first problem. But the second problem, we can include the equal to, which technically would mean that on the -3 we would do a bracket, and on the -2 we would do a bracket. However, I can't use -2 because if I plug a -2 into this fraction, it makes a 0 in the denominator. So even though we typically will bracket with the equal to and parenthesis with the not equal to, we have to make that adjustment right here because of this rational function. We don't want it to become 0 in the denominator. So we're going to leave this one as a parenthesis to exclude the -2.